In today's video, we're going to discuss more mathematical models. In particular, we're going to start discussing interest. We're going to go over simple interest as well as compound interest and discuss why those are so important and why you need to know them. But as we do in all of the class sessions, I want to go over the homework that's expected for the next class session. So we're in week 4. For the homework, the assignments and assessments, you have 3 assignments that you need to complete. You need to take care of the Module 2 project, essential questions. You can see that down here. You get to it by going to Module 2, mathematical models, assignments, and it's there. The second assignment is the Module 2 is buying bigger, better report. Again, you go into Module 2, Mathematical Models, Assignments, and the assignment is located there, is buying bigger, better. And then the third assignment that you're expected to have complete is the Module 2 Reflection. Now, all 3 of these assignments are due by October 8th. If you have any questions, feel free to reach out to me. Before we start talking about simple interest versus compound interest, we first need to understand what interest is. Interest is simply put the money a borrower pays to use a lender's money. In a sense, interest earned that you earn is like a reward. And to put it in sports terms, that's just like scoring a touchdown, hitting a home run. It's something that you want to receive. You want to receive interest payments. Interest paid, however, is like a penalty or it's like a foul. So you want to earn as much interest, but you don't want to pay as much interest. Simple interest is based on the entire amount of the loan for the total period of the loan. So the simple interest formula is I equals P times R times T, where I stands for the interest, P stands for the principal, which is the beginning balance, R stands for the rate or the interest rate, and T stands for time. That's usually in years. If you receive, well, we'll do some examples of if you receive information about months and how to convert it into years. Simple interest is when the interest is calculated based on the amount borrowed and the same amount of interest is paid each year until the money is paid back. So we're going to do a couple of examples of how to calculate simple interest. As you see at the bottom, you're going to see this on the rest of the slides. Time is money. And after we get done talking about compound interest, I think you'll understand why the saying time is money is so important and it's something that you want to get involved with. All right, so what we have here are 3 separate examples of how simple interest is calculated. All right, so in the first question, you see it says find the interest on $1,000 at 6% for 2 years. So we're going to try to find what I equals. And based off of the information, the first thing we have is the principal. So the principal amount is $1,000. The interest rate or rate is 6%. And the time that we have available or what it's asking for, the time period is 2 years. All right, so if we just put that in that equation, so we'll use parentheses, so 1,000, and we can use the times symbol. So 6% is the same as saying 0.06. That's what 6% equals in the decimals. And then we'll times 2. So again, the principal or the P is 1,000. The rate or the interest rate is 0.06 or 6%, and the time is 2 years. So after we have that into our equation, I equals, I'm going to open up a calculator. So 1,000 times 0.06 times 2. So the interest that would be paid is $120. But the total amount that would be paid back is whatever the principal is, which is $1,000 plus the amount of interest that's collected. So that would equal $1,120. So that's a very easy example of how simple interest is calculated. For the next example, we're going to use something a little more real world. So people have car loans or car notes, and depending on how much the principal is and the interest and the number of years that you have to pay it back, you can kind of get an idea of how much interest you you pay, the total amount of interest. And we just pretty much do the same thing that we did before. So the principal for the car loan, principal is equal to $15,000. The interest rate or the rate is 4.25%, so 0.0425, and the time is 5 years. So we're just going to enter that into our equation. So I equals 15,000, and this time I'll just put them side by side without using the multiplication symbol, times 0.0425 times 5 years. So if we go back into our calculator, we have 15,000 times 0.0425 times 5. So the total amount of interest that's paid is $3,187.50. But the total amount that you'll pay back for that car loan would be equal to the principal amount plus the interest that you paid. So $3,187.50. And we're going to add those together plus 15,000. So $18,187.50 is what you paid back. So 187 187.50. So that's the total amount that you pay back for that car loan. It has the principal amount as well as the interest that you pay. For this next example, we don't have years, but we can convert months into years. So find the amount paid back on a loan of $1,200 at 8% for 3 months. So we just want to, instead of trying to know what we paid back within that year, all we want to know is how much interest or how much of the loan did we pay back within 3 months, not a full year. So to do that, again, we just get all of our information. So the principal amount is $1,200. The interest rate or the rate is 8% or 0.08. And the time is 3 months. So we know that it's 3 months and we know that there's 12 months in a year. So we're going to do 3 over 12. So that'll allow us to calculate the interest payment for 3 months. So we'll put it in our equation. So I equals the principal amount. And this time I'm going to use the multiplication symbol or the asterisk times 0.08 times 3 over 2, which is equal to, let's just put 3 divided by 12, 0.25. So it's a quarter of a year. So 0.25. And so we know that the interest, total interest that we paid is 0.25 times 0.08 times 1200. So $24 within 3 months. That's how much interest we paid. So $24. So the total amount that we paid is the interest payment plus the principal amount. So 1200 plus 24. So that'll give us $1,224. So that's the total amount that was paid. So the next thing we're going to discuss is compound interest. Um, it's referred to as the eighth wonder of the world. And this is where time is money actually comes into play. You'll understand why time is money. So it's called the eighth wonder of the world because the earlier you start collecting interest, the bigger the total amount ends up being. So that's why time is money. So again, I'm going to start off with the definition of the word interest. Interest is money that the borrower pays to use a lender's money. Again, interest earned is a reward. So that's just like you're scoring a touchdown, you hit a home run, you scored a 3-pointer. Interest that you pay is like a penalty or like a foul or a violation. So you want to collect as much interest as the interest that you pay out. So compound interest is the interest earned not only on the original principal, but also on all interest earned previously. So, in other words, at the end of each year, the interest earned is added to the original amount and the money is reinvested. So, this is where that money, time is money, and money starts working for you. And the equation to calculate compound interest is A equals P times, in parentheses, 1 plus R over N, end of the parentheses, and then times NT, or exponent NT. So A stands for the amount that accumulates in the account. I, again, is the interest rate. P is the principal, or excuse me, interest. I is the interest. P is the principal. R is the rate, the annual interest rate as a decimal. T is the time in years. Again, we're going to try to keep using years, but if we get a problem where it starts talking about months, we know how to convert it into years. And then N is the number of compound periods per year. So as we do with all of our definitions and terms in math, we have to do some type of example to hopefully give you an ideal of what that definition means and what that equation is used for. So in this example, it says at age 20, Taj decides to invest $2,000 annually for 5 years. Taj's friend Jan decides that she would rather wait, not wait until she is in a better place financially. So Jan doesn't start investing her $2,000 a year until 5 years later at age 24. Who has more money in the 10-year span of investing? All right, so this should actually say 25. She waited 5 years after, so it starts at 20 for both Taj and Jan. So again, we're going to use the equation A, and actually, let me think. We'll put the equation down here. So A equals principal, and in parentheses, 1 plus the rate over number of compound periods. And then I'm going to use the caret for the exponent. So that's the equation we're going to use. So the first 2 years, or the first 5 years for Tosh, she is investing $2,000 each year. And then for Jan, we're going to add $2,000 to her amount once she turns 25. All right, so we'll start with Taj. So if we drew it and use black ink pen, so A. So this is for 20. So I'm gonna put in parentheses 20 equals, that 20 stands for 20 years old. That's her age. So I can get an idea. So we know that the principal amount is that investment that she's putting in. So 2,000. And we're gonna put 1 plus the rate is, we put the rate in there. The rate is 11%, I believe. It doesn't say, but the rate that we're using is 11%. So we'll put 0.11 divided by, and then the number years, that's 1 year. And then the n, or the number compound, is 1 times, and it's 1 year. So that just equals 1. So if we were to so 0.11, so that would equal 2,000. 1 plus, we know that that's 0.11, and we know that that's 1, which we really don't need to put that 1 there. And then that would equal 2,000 times 1.11, and 2,000, so 2,000 times 1.11 equals 2020. So that equals 2020. If we go up here, the total value after that first year is $2,220. So the next thing we're going to do, we're going to get rid of that, and we're just going to put the age 21 because she's investing again. And the principal is whatever the previous value was. So that's 2,200. Oh, I might want to erase that. Let's erase that. Let's erase that as well, because that's going to change. All right, so we have $2,220. We're going to use the same 1 plus R over N, which is, the rate is 0.11. The number of compound periods per year is 1 per year. And then the N times T, or the number of compounds per year times the time, which is 1 year, that's 1. So we're going to put our 2020 in there. 2,220, and 2020. That shouldn't be 6. That's 2,220 times 1.1. And if we do that, so we'll do times 1.11. That gives us $2,464.20. But because we had money, we did make an investment, the 2,000 investment. We invested 2,000 again for our 21st when we were 21. So we would have to add that $2,000 of investment. So that makes the total value $4,464.20 because you're adding the investment plus that amount that accumulated because you're still making money off of this $2,200, $2,220. But you also invested $2,000 that year. So not only are you investing money, but the money that you invested the previous year is also making money. So in age 21, Taj has $464.20. All right, so next we're going to do age 23 for Taj. So age 23, we're just trying to calculate the interest that's accumulating. So we're going to use that $4,464.20. And then we're going to use the same numbers. So I'm going to skip past this because we already know what those numbers are. And we're just going to go all the way down here and we're going to enter $4,464.20. And we're going to multiply that by 1.1. Again, it's the same number. We're using the 1 for that's kind of constant, plus the interest rate, which is 0.11 or 11%, over the number of compound periods per year, which is 1. And then that's in the parentheses, and outside of the parentheses is NT. And again, I'm just using that equation right there. So NT, so again, the number of compound periods per year is 1, and we're only looking for 1 year. So that's why these numbers right here are going to stay the same. This is the number that's going to change. So we're going to multiply $4,464.20 times 1.11 equals, so $4,955.26. But Taj also made another $2,000 investment. So we need to add that number. So we got 4,495 or $4,955.26. But we need to add 2,000 because Taj, again, she invested $2,000. So the money is just going to keep accumulating. So we need to add 2,000 plus 2,000. That gives us $6,955.26. So we need to put $6,955.26. So next we're going to move on to age 24. So again, Taj is still investing $2,000. So this will be the fifth and final year because she started at 20. So she invested 2,000 dollars at 20 years old, another 2,000 at 21 years old, another 2,000 at 22 years old, another 2,000 at 23 years old, and then the final amount is the final time that she invests is at 24 years old. So I need to get that amount, 6,900. Oh, so it looks like we do have that amount for that year. Okay, so we're not at the last one. The last one is 23. So we're on 23. So I messed up my numbers. That should have been 22. Sorry. So this was 22. Now we're moving on to 23. Got a little ahead of myself. So let's go ahead and scribble that out and put 23 here. Yeah, so I used the wrong number. So it should have been, we just completed age 22. Now we're moving on to age 23. So again, the only numbers that are going to change is this 4,000 number. So we're going to get rid of that. These numbers right here, the 1 plus 0.11 over 1, 1 times 1, that'll stay the same. So I'm going to get rid of this number here. Get rid of that. And so the number that we use for 23 years old is 6,900. So $6,955.26. So the reason why we're using that number is because we're just trying to figure out how much interest is accumulating. That's all we're doing, is figuring out how much interest is accumulating while we continue to make a $2,000 investment. So what we're going to do is we're just going to take the same numbers, $6,955.26, and multiply that times 1.11, and that equals $7,720.34. But again, Taj made a $2,000 investment, so plus $2,000 for that investment, which leaves us with $9,720.34. All right, so we're going to put $9,720.34. All right, so we're going to move on to age 24. So the amount that we're trying to figure out as far as interest, we're going to use that $9,720.34. So $9,720.34. So we're going to use that amount to figure out how much interest has accumulated. So we're just going to take that and multiply that by 1.11 like we did the other ones. And multiply that 1.11, and that gives us $10,789. But again, Taj invested $2,000 for the last time, so we need to add $2,000, and that gives us $12,789.58. All right, so I went on ahead and entered the total amounts because again, the amounts are accumulating every year. We're just putting the previous number in and multiplying it by 1.11. So once Taj gets to 29 years old, she has almost $30,000, and that's off of a $10,000 investment. So we're going to move on to Jan. Jan didn't start investing until she turned 25. So the fact that she started investing at 25, there's nothing that accumulated from that $2,000 investment because she started off with zero and there was nothing to add on. So at the end of 25 years old, Jan has $2,000. So moving into 26, age 26 for Jan. So we'll put 26, 26, and we need to delete these numbers right here, but we're going to keep the 1.11. We're just changing that. So we have 2,000 because that's what was the initial total value. And then we're just going to multiply 2,000 times 1.11. But instead of just including the amount, so when we multiply 2,000 times 1.11, that gives us $2,220. But we need to add on that other investment of $2,000. So plus $2,000, and that gives us $4,220. So at age 26, she has 4,400. Hold on, let me make sure I have that number right. 4,220. So $4,220. So moving on to age 27. So we need to get rid of that, get rid of that, get rid of that. Moving on to age 27, we start off with $4,220, and we're just going to multiply that $4,220 times 1.1, and that gives us $4,684.20. But because she made an investment of $2,000, we need to add that in. So the total value is now $6,684.20. So $6,684.20. All right, so moving on to age 28. We need to get rid of those numbers, and we need to put $6,684.20. So she's invested another $2,000, but we're only trying to figure out the accumulative amount at age 28. So we're going to multiply $6,684.20 times 1.11. That gives us $7,419.46. But again, Jan, she invested another $2,000, so we need to add $2,000 on, which leaves us with $9,419.46. So we have $9,419.46. Yep. All right. So we're on that last year now at 29. So at age 29, we start off with $9,419.46. And we're just going to multiply that times 1.11. So times 1.11, and that equals $10,455.60. So she did invest $22,000. So we need to add that to $2,000, and that gives us $12,455.60 total. So we're gonna right, so we end up with 12,000. Am I typing? $12,455.66. Let me make sure I type that in there correctly. All right, 450 and 60 cents. Sorry. So let's take that last six out and put 0. So you can see at age 29, Taj has almost $30,000. At age 29, Jan has $12,456. So you can see one thing you want to realize, like I said before, the sooner you start investing, the more that money will accumulate over time. And this is why compound interest is called the eighth wonder of the world, because of how the totals just keep accumulating year after year after year. So you want to start off as soon as possible when you want to start investing. Again, this is is interest earned is just like you're making your money work for you instead of you working for your money. So the sooner you start making your money work for you, the more interest will accumulate over time because of compound interest. And in the last video, we discussed budgeting. In this video, we're discussing interest and sort of talking about investments. Well, this is all a way to prepare yourself for financial freedom. Budgeting is that's that initial step to financial freedom. That allows you to prepare for any unexpected expenses or to save for things. Um, Investing is a way for you to prepare for things like um, inflation, where every year the prices are going to continue to increase. But if you're investing and you're getting a decent return, anything over 3%, then you're going to be prepared for that inflation rate. So that's pretty much the video. Hope you enjoyed it. And if you have any questions, just put them in the comments section or email me.